This is a quick little tutorial on significant figures. Whenever we take measurements, we have to figure out everything we're certain of, and then you're allowed one estimate. And that is the idea of significant figures. And when we're calculating and reporting these, it has to be based on a real measurement. So for instance, if you were to say, if these were like centimeters, let's say, and you said 2.55, that would tell me that you were certain of the 2, you were certain of the tenths place, and then you're estimating, because you're allowed one estimation, the hundredths place. On the other hand, if you said 2.5, that would tell me you're using a totally different ruler. And again, this is in centimeters because we have to have units. So these numbers mean a lot the way they're written. It implies what kind of instrument that you're using. So the bottom line is every digit that we're certain of in a measurement, and then the first and only first one that's a guess, is what we consider significant numbers and figures. And now we're going to figure out how do we calculate with those, and how do we determine how many significant figures are in a measurement. So there's a couple rules, and the first one we're going to deal with is anything bigger than the number 1. And it's usually figuring out all whole numbers usually are significant, are significant, but then it's the zeros that we need to figure out. Are they placeholders, or were they actually measured? And the way to do that for any larger number than 1, without a decimal point, the trailing zeros at the end are not significant. Everything else is. So if I have 2,300 kilometers, it just means the 2 is significant. The 3 is our first guess. That's significant. These are just placeholders. They could mean 2,300 kilometers, 2,200 kilometers, 2,400 kilometers. That 3 is uncertain. It was probably measured with somebody's car, maybe. If I say, let's say 2,300 and there's a decimal point there, maybe they're talking about like an Olympic track meet or something. Then those would all count. Now, when it does have a decimal point, like this one, basically all those zeros count. Okay, that is just not a placeholder. 234, three significant figures. So again, that's one way to tell for numbers bigger than 1. Now, what about if there's numbers smaller than 1? Well, for any number smaller than 1, with a decimal point, the zeros from the decimal point to the first whole number are not significant. Usually everything else is. So for instance, this is less than 1. There are no zeros. All those are significant. We're certain of these 2 numbers. This is our one educated guess. This one, 4 sig figs, again, there's all the whole numbers. The zeros are in between whole numbers. Everybody counts. The only time they don't count is when it's between the decimal and the first whole number. Those are just placeholders. So 1.0023 grams, there's only 2 sig figs, these 2 whole numbers. If that were 0.00203, that would be 3 sig figs. If it were 0.00230, that last O would count. Those 2 would count. It's just the ones from the decimal to the first whole number. Okay, so next, we need to look at, okay, this is kind of nice, and I actually stole this from Geyer. I don't like lots of rules, and he came up with a simple idea. And this is really kind of cool. It says dot right, not left. Okay, so how does this work? For any one of these right here, if there is a dot, like right here, okay, the rule is you cruise to the right. The first whole number, you go up and over, and anything underneath is considered significant. So for instance, there's 4 sig figs there. If I go back here, let's go to this one. Again, dot right, there's a dot there. I start over here, I go to the right, up and over at the first whole number over, there's 2 sig figs, okay? I can pick this one. I go over, hit the first whole number, up and over, 3 sig figs. Anything underneath, that counts. This one up, I hit that first whole number, up and over, 4 sig figs. It's all those under that area. That works great. So dot right, that's what dot right means. If you see a dot, a decimal point, you go to the right. And then the other part of this is not left. What does not left mean? Well, hey, look, check this out. There's no decimal point here. That means I will go from the left over, hit the first whole number, up and over, there's 2 sig figs. Okay, there you go. Over here, up and over, there's only 1 sig fig. I didn't draw that very well because my mouse doesn't work well, but there's just 1 sig fig up and over. That 0 doesn't count. Either rules work fine. Okay, so next, once we have these, we need to figure out how are we going to calculate with these. Well, let's take a look. Now, easiest thing I can tell you with this one is, here's what we would like to do. Anytime you are adding or subtracting numbers, the key, and again, I'll read this through, but it's easier just to show you. When adding and subtracting, the leftmost significant digit in the problem, so here, these are the ones in the problem, what we're adding and subtracting, is the rightmost significant digit in the answer. And here's why. In 123.45, that 5 is uncertain. In 23.1, the 1 is uncertain. In 1.111, this one, again, is uncertain. Now, when I add all these together, my calculator doesn't get it, and it's just going to give me this big old answer right here. But if I look at this answer, this 1 is uncertain, so this one must be uncertain. This 5 is uncertain in the hundreds, so this must be uncertain. This 1 must be uncertain in the tenths place, which makes this 7 uncertain, and then these we're okay with. What does this tell us then? Well, look, all that we're certain of and 3 that we're uncertain of. We can only have 1, and it's the first one. So we can keep this guess right here. How do I round? 5 and above, round up. 4 and below stays the same. This is 6, that's above 5, 147.8. That's how we do it. Now, that's for addition and subtraction. Let's say we would like to do multiplication and division. Basically what you do is whatever you're multiplying and dividing, and we'll be doing this a lot in chemistry, look at the number of significant figures in each one. Okay, dot right, I go across, up, over, this 12.00, 4 sig figs. Again, 3.00 milliliters, that's 3 significant figures. When we multiply and divide, we essentially take the least number of significant figures in the problem, and that's what we have to round to in our answer. So if this is 12.00 divided by 3.00, on my calculator, it might read 4.00000000 or go on forever. We can only keep 3 sig figs, so we round it to 4.00. And that's how you do multiplication and division. Now, the other thing that is a little confusing for people, and I want to make sure you understand this, is that these rules are only used for measurements. Many times we will be doing converting. Like I might say you've got 15 miles and we want to convert it to kilometers. And then the conversion factor, 10 kilometers equals 6.2 miles, that's considered an exact number. It's not a measurement. It's what scientists have determined. So we consider that an exact number. So you don't have to worry about the significant figures from exact numbers. So if you have, like, let's say 15.2 miles, which is 3 sig figs, and you want to convert to kilometers, then you'll have 3 sig figs also when you convert to kilometers or whatever other length that you convert to. And we'll talk a little bit more about this in conversion. Okay, so what I'd like you to do, make sure you take notes on this, make sure you have notes. And then also make sure to answer a couple of problems in the Google form, and we'll bring these to class and hopefully do some problems in class.